Good day, students. Today we are learning about stacks in data structures using C language. So let's go. What are the different topics in stacks? First, what is stacks? Stacks is a linear data structure that follows the LIFO, last in first out principle. What is the meaning of that? Means we can store the data or we can do the different operations, but here last in, the variable will be last in and first will be out. We'll learn how we will follow that. And not only stacks, we have the another one operation is the queue operations. So here we can use the queues also, but queues have the both the ends, two ends. We call it as in a front end and rear end. We can input the values or we can add the values in the both the manner, but in stacks we can only add the numbers at the top of the element only. We call it as in a top. We can add the element in the top and we can delete the element in the top only. That's why we call it as in a last in first out. Okay, let's go. What are the different examples of stacks? See here a file of books, stacks, dinner plates. These are will place one after one like potato chips. So we will get the first one after deleting the last one. We can delete the last in, then we get the first one. Okay, this is a stack operation. Let's go for the next one. Some key points of stacks. So we know about the abstract data types. We learned it in the last class. So here stacks also follows the abstract data types. Okay, then I have to go for the next one. Here standard stack operations. What are the operations we will perform by using the stacks? See here, push operation, pop is empty, is full, and display. These are the few operations we will operate in the stacks. First of all, what is the push operation? Push means in the stack we can insert the elements or we can load the elements in the push operation. Then I have to go for the pop. Pop means we can delete the elements. So we call it as a deletion of element in the stack. We call it as a pop operation. So in the time of these pushing or popping or different actions, we know the list is empty or not. So the stack is no elements. We call it as an empty. So we get the empty of the list. And sometimes maybe the stack will be full. So the full means already stack got the all the elements. So we can't put the another element. We call it as a stack is full. And then after we have another option like a display. Display means whatever the things we can see, the different elements we can see in the output manner. We call it as a display. Next, what is push operation? See here, before inserting a stack, so already I said push means we are inserting an element to the stack. Okay, so before inserting an element, we should know that the stack is empty or not. We only insert the elements if the stack is empty. If the stack is full, we can't insert any element. First, we should select that. So we give the conditions first and we check the stack is empty or not. That means the stack is a space or is there or not. After if the stack have some space, then we can insert the element. How we can insert the element? Just we are giving the option top plus 1. After giving the top plus 1, it will give the first location. And then after plus 1 means next after we will give the maximum elements. So n elements, we call it as an n elements. So we can fill the n elements to the stack or push operation. Then after we can go for the next one. Push, and next one is the pop operation. See pop operation. See here the pop operation means, see the stack is full. The stack has some elements, but I want some elements want delete. So here I am using the pop operation. Pop means deleting the elements. Top equal to 3. So top position is a 3 for the third position. So 0 to n elements. So 0 to n elements means here top in the position of 3. Okay, so here I'm deleting the last element. Okay, now I'm the first element in the stack is the last element for 40, and then after go for the next and the next one after top minus 1. So every time I'm giving the top minus 1 means one element will be deleted. After completion of the every element, first it gives the stack is full. After filling the elements, it gives a stack is full. Okay, then after one by one by one by, I'm deleting the elements. After deleting the every elements, stack is empty. Okay, then after pop operations, we have here we have a one operation in the time of popping, means underflow. So underflow means top is already empty. So in the empty stack, we can't delete any elements. So it gives an underflow condition. We consider top equal to top minus 1. So no element is there. We can't delete any element. We call it as an underflow. Okay. Then after push operation. See, last time we called it as a pop operation. Deleting element, we called it as a pop operations. Here inserting an element, we call it as a push operation. See, top equal to minus 1. That means the stack is empty. Then after top equal to 0. 0th location means top got the one element. After pushing the next element, pushing means here just top equal to top plus 1. So already top is plus 1, one element is there. So then we are plus 1 means the next position will allocate. So next element will place it in the top of the stack. Like in the same way, every elements will be placed in the stack. After placing all the elements, stack will full. We call it as a stack is full. That means the space and elements are filled. No space is there. Okay. Then have to go for the next one. Representation of a stack in as an array. So you know very well about the array. Here we are representing the stacks by using the array. How the array will be represented means it gives the sequential order. Okay. So here also I'm taking defining a maximum 50 members. So size, maximum size equal to 50 members. That means 50 items I can add in the stack. Okay, maximum size. See, I'm taking as a structure stack and top equal to, so I take the top is the first element, that's why I'm taking it int top. Okay, int item equal to max. Maximum means the elements, how many elements we want to add. Okay, now see here item are placed from the item 0. So top minus 1 equal to the null value. Okay, nothing is in the stack. After getting the first location, it gives the top item equal to 0th location is the first location. After that plus 1 plus 1, then after we will get 1 0 so 0 1 2 3 like in the same way. Okay, then after go for the next one. The stack is represented in the memory as A, B, C, D, E. So E is the top. So A is the first element. It will place it in the down of the stack. And the E is the last element. It places it in the top of the stack. Okay, here we can place the element first, but we can delete the element at last. Okay, now see here, for example, I want to delete A, but I should delete E, D, C, B. Then only I can delete the A element. This is a stack representation. Okay, stack represented with the help of array, using a array. Okay, then I have to go for the next one. Element on the stack push operation. So how we can push the element? See here algorithm. See the algorithm. Here incremental value means the every memory next to location. So first location, the first location will take the reference of the next location. So all the elements in the stack will link to each other by using the linked list application. Okay, and we can here we using the array applications. Array means a sequence. Okay, by using the array, so this is the algorithm. See the algorithm. First we will have begin, then after if top equal to n, then the stack full elements, n elements are filled. Otherwise top equal to top plus 1, stack top equal to item. So every item will be placed in the top. Okay, after getting the last n element, the stack will be full. Okay, then after go for the next one. Deletion of the element. Last time we saw the insertion of the element. Now here we are deleting the element in the stack. Okay, so here we are deleting the element means top element will be deleted every time, and every time we can delete one element only. Okay, by using the array. So here see the algorithm. First begin after take top equal to 0. If top equal to 0, then stack is empty. Okay, stack is no value. So here if stack have some elements, then item equal to stack top. So top equal to top minus 1. top equal to top minus 1, every time one element will be deleted. So minus 1 means it comes the down. For example, top equal to 3. So I gave here minus top minus 1. Automatically it comes to the 3 to 2. So next 1, next 0. Like in the same way here we get delete all the elements. Then have to go for the next one. Representation of stacks as using a linked list. So here we can use the stacks by using linked list also. So you learned about the linked list. Linked list means just a data and link element. Okay. Here also we can represent the stack by using the linked list. Okay. By using the linked list, here see the structure stack into data and the structure the pointer variable link. Every time we can link the pointer. What is the difference between array and a linked list means array is the sequential manner, but a linked list is a dynamically stores the elements and we can link each element with the order, stack order. We following the stack order. So here the element order from top to bottom in linked list represent left to right. So next go for the next one. See the C we can using the C language, that's why stack structure stacks into data structure link, how their elements are will be represented. See here top equal top element, the first element 15 is the top element actually, but the first element is 44. First element is 44, second element is 10, third element 20 and fourth element is the 15, but it is located in the third position, 0 to third position. Okay, now see the stack contains 4 elements. First one is the 15th element. Okay, but it is the stack top element. See the top element of the stack. Okay, so 44 will get the null. Why? Because the 44 doesn't have the link element. 44 is the first element. Then after next element, next element, next element. By using a linked list representation, we can give the link between these elements. The elements will be stored whatever and whenever, but it gives the link between those elements. Okay. Then have to go for the next one. Adding a node to the stack, or we call it as a push operation. So how we can push the element in the stack operation? See here, void push is an operation. We are using the method, or we call it as a function, push function. So here int value and got a value as an int value, and this is the structure node is the memory allocation, dynamic memory allocation for the nodes. And then after if ptr equal to null, so if the ptr equal to null means not able to push the element. Okay, because it is a full always. Okay, and not it is an empty always. Okay, then have to go for the next one. Else we can add a element and print a value. Then after how we can add an element? After adding an element, the element will scan and maybe this one is the top element, maybe. Okay, if the head equal to null, that means the element is the first element. So ptr equal to value and ptr next equal to null because it is the first element. Okay, then after head equal to ptr. Else maybe the element is the next element, whatever the next element, already it have some elements, starting elements or some elements. Here we are giving the next element. We call it as a ptr value equal to value, ptr next equal to head, or ptr head equal to ptr. So automatically one element will be pushed and it gives the link between the next element. Okay, so the next element with head, both the elements will be linked together. Okay, by using the address. Okay, this is the adding an element. Okay, then after go for the next one. So now deleting an element by using the stack, we can delete operation also we can do by using these. Before deleting, we should check for the underflow condition, adjust the head pointer accordingly. Okay, now so deletion means we are removing some element. Okay, so we are removing some element means we can give the adjacent element. Okay, how they will perform. See here, void pop. So item, we got it as an item. If head equal to null, underflow. So that means no elements are there. For nothing is there, we can't delete anything. Okay, that's why we got as an underflow. No elements are there. Else we have some elements. So maybe the element is a head value. Okay, so head value 2, we give the link to the next value. So if the head value free, see here First item equal to head value, PTR equal to head value is we are giving the connection to next value and we are deleting the PTR. So already PTR have the head, okay, so the PTR will be free, means here deleting. So print on the here item popped. So next element will be the head element, okay. Then after go for the next one. Applications of stacks. So we know about the mathematical expressions, we call it as an arithmetic expressions, like different types of operands or operators. We are available and constants, different types we will be use like subtraction, addition, multiplication, division. So here we have some example, like see the example a plus b into c by d. So here we should follow the mathematical expressions, or we should follow the rules to calculate these expression. So which operation will go first preference and which operation will be go the last preference. Here we have some references here. Precedence, we call it as a precedence of operators like unary or unary plus, not, these will are last precedence, other than the sixth. And we should go it as in a right to left, like exponential is in a sixth preference and we'll give the right to left. Multiplication and division is on a fifth preference and left to right, and addition and subtraction is the fourth preference, left to right, and deletion, sorry, here greater than or equal to, less than or equal to is the third position, and left to right, and is the second, and left to right. Next or XOR is the first one, is the left to right. We should follow these rules, then only we get the accurate answer. So mathematical calculations like addition, subtraction, or combination of number of operations, okay. Then after go for the next one. So we following these rules by precedence. 15 5 into 3 15 plus 4 minus 2. After that we getting addition, and 19 minus 2. Then finally we got the answer 17. So we called as a notation of arithmetic expressions. These arithmetic expression notations are infix notations, prefix notation, postfix notation. So here what will be happen in the infix notations? These are using in the time of arithmetic expression by using the stack operations, okay. So here in the time of infix operation, conventional way of writing as an expression is called as an infix, when the operand will be first location and operator in the middle of the operand, and both the operands, operand 1 and operand 2 in the middle of the operator. We call it as an infix. We call it as an infix, okay. Then after go for the prefix. In the time of prefix, see the notations places like operators is the first position. Operator is the first one. Next operator 1 and operator 2 be placed. Okay, see in the example in the infix a plus b we wrote. Okay, in the prefix first we will write the operator plus, then after we will write the operand a and operand b. Okay, then after go for the next one. For postfix, last one is the postfix. See the postfix, the notations are operator 1 and operand 2, then after we go for the operator. See a b plus, so we call it as a postfix, okay. So how we can convert these expressions? We can convert the expressions infix to expressions to postfix, or maybe infix expressions to prefix, okay. So here we have some example like infix to postfix. See the algorithm: print the operand as they arrive, okay. Then after stack is empty or contain left parentheses, or the push the incoming operators on the stack. Then after symbols like different symbols, mathematical symbols in the on the stack, okay. So after pushing all the operators, we will get the expression. Okay, for one after we should follow the expressions. So we will get like in this way. Okay, first current token we are posting infix to postfix. That's why expressions are in the last of the operators. Okay, see these are the operators of stacks. Okay, this we call it as a postfix. How will you say this one is the postfix? Because operators are in the starting and the operators is the ending of the expression. So we call it as a postfix. Okay. Then I have to go for the next one. Converting infix expression to prefix. So I'm like in the same way only here also. First to reverse the infix expression to the given problem. Then after sack the every element from left to right, and whatever the arriving print them. Then after we follow the empty or simply push the element of the stack. Then after pushing one of the top of the element, then after coming to the next element, we will follow these rules. See, after pushing all the expressions, like the stack will be in this position. See the expressions, bracket a plus bracket b into c bracket closing slash bracket opening d minus e closing bracket and closing bracket. So this is the example. We call it as an infix example expression. Okay. Now we want to post it to the prefix example. So in the time of prefix, every expressions will come to the for example, every symbol or every operators will come to the front of the operand. Okay. See here the parentheses or the expressions will come to the operand. Okay. So the result is plus a slash into bc minus da. Okay. Here the conversion of this expression, infix expression to prefix expression. This is the answer. Okay. Then I have to go for the next one. So define queue. So in the time that we learned about the stacks. Stacks means pushing the element or popping the element. We can push or pop in the one way only. Stack always have a top only. So after pushing the elements only, we can delete the element. So we call it as a popping. After pushing element, we can pop. It is only have one top only stack. But we have another one, we call it as a queues. So in the queues, we have two ends. We call it as a front and a rear. Okay. So we can insert the element and we can delete the element. Here we can insert the element, can be defined in order in the first which enable insert operation will be performed. One end called the rear. Okay. Now we can perform the another called the front. Okay. So first see reference to the first in first out. Here stack will follows first in first out. Listen once, stack follows first in last out. Okay. But in queues first in first out. Like standing in the queue, ticket queue or any queue, see the symbol. This is the front part and that one is the right part. Okay. So the DQ and NQ. So we are deleting the element or we can insert the element. So here first element will be go to the first deletion. Okay. So every time we can insert the elements. Okay. So we can do both the operations like a deletion operation and inserting operations. But first element will be deleted in the first in the queue order. Okay. Got it? Next one, go for the next one. See a representation of queues. We call it as a DQ, deletion, front ender, rear part, rear ender, NQ. Okay, DQ and NQ. First element, second element, third element, fourth element. We can delete the first element first only and the second element in second time. Okay. Now see the next operations on the queue. Okay. See we have a different operations like NQ, DQ, queue overflow and queue underflow. So here NQ means the operation to insert an element. See here NQ. NQ means we can insert the elements in the array. Okay. And thus in the same time we can delete the element. So delete the elements in using a DQ. DQ means we are deleting an element in the queue in the front only. Okay. Then after C here we have two conditions like is a full or empty. We'll call it as a stack overflow or a stack underflow. What is the meaning of overflow or underflow? So queue overflow means it's a full. We can't insert any elements. So the the queue's maximum size is filled. N elements are filled. No one element can insert. Okay. Otherwise, we can get the next operations like a queue underflow. What is the meaning of underflow means is empty. So if the stack is empty, we can't delete any element in the queue. Okay, so these are the operations we can perform in the queues. Okay, then after go for the next one. We have a different types of queues like a circular queue, DQ, priority queue. Okay, what is the meaning of circular queue? See here, circular queue means see in the picture First we are starting with 1, 2, 3, 4, 5, 6, 7. So after the last element will combined with the first element, then we will get the completion, that end part will be added to the front part. That's why we call it as a circular queue. Okay, then after DQ means double-ended queue. The double-ended queue means here both the edges have the insertion point and deletion point. We call it as a double-ended. Okay, now next after priority queue. Priority means we will give the priority of which end. Maybe we can delete one element and we can add the element one side. Which one is a priority, you will take it in your way. Okay, now see, double-ended queue can be represented in two ways. Those are input restricted double-ended queue and output restricted double-ended queue. Means we can add or we can delete elements in anywhere, but we should give that particularly. See in the picture, insertion and deletion. But the second picture, see, input or restricted double-ended queue, we can add anywhere, but we should give one way only. So here I am inserting in the front, okay, and I can delete the element in front and rear. We call it as an input restricted double-ended. Okay, so we should give in a front input only, and we can delete the element both the ends, like a front end and rear end. Okay, next then after go for the next one, output restricted double-ended queue. Here see in the picture, so front part is there and rear part is there. Here we can insert the element in the front part or we can insert the element in the rear part, but we can delete the element in the rear part only. So we can give the instruction to the output for any one side only. Then after go for the priority queue. So in priority queue, we know the elements, where the elements store according to the priority levels. We have some algorithms to give the, which one is to give the first priority, decided by taking the some algorithms. Okay, this is the priority queue. Okay, and after go for the what is queue. See here, first of all, what is queue means, see here, storing the elements like HELLO. Hello is the stack, queue. We are storing the elements by using a array representation. Okay, this is a 0th location to 4th location. We have 5 elements. Okay, so here we give first one, if rear equal to maximum minus min, so right overflow. That means we got every elements. Okay, go to the end. Okay, then after go for the next one. If front equal to -1 and rear equal to -1, maybe front and rear both the -1 means no elements are there. So set front equal to rear equal to 0 and means a 0th location, the first location. Else maybe set rear equal to rear plus 1. Plus 1 means next location. So next location, next to next location. Set the queue or number or exit. Okay. Then after go for the next one, algorithm to delete an element from the queue. So here we are deleting an element in the queue. So queue can delete the element by using the delete operation, like here. See the algorithms. If front equal to -1 or front greater than rear. So greater than rear means maybe it's the biggest number. See, write the underflow. That means no elements are there. Okay. Then after go for the next one, set value equal to q front. So we are giving the value equal to front one. After giving the front one, so set front equal to front plus 1. So we can delete the element. Okay. Then after go for the next one, step 2. Linked list implementation of queues. See here, linked list implementation. So we can give the queues by adding a array, or we can give the linked list. So linked list means giving the link between the each elements. Okay. Two parts of a see, like a front in front also we have two parts, like a data and a link. So first box is the data value and the next box is the link value of the next element. So always it stores the elements in a random way, but it gives the link between those elements by taking the link data. Okay, so linked list representation, see in the operations. Insert operations, like in the insert operations we see the algorithms. PTR equals structure node is the memory allocation. Step 1, see, they allocate the space for the new node PTR. Then after set PTR equal to data equal to value. Then after if PTR equal to null, so nothing, front equal to nothing, null means set front equal to rear equal to PTR is the first element. Okay. Then after set friend equal to rear equal to next element. So next element we call null means nothing is there. So if null means we can add the next elements. Else set rear equal to next equal to ptr. Set rear equal to ptr and next equal to null. Like in the same way we can add the number of elements. First it will gives the null pointer means nothing is there. Then after next it gives the rear means first element and the link equal to null. After getting the next value, the link will be filled with the next element. Here we are deleting the elements. So last time we learned about the insertion. Here we are learning about the deletion of or removal of the elements. How we can remove the elements. See here algorithm in front equal to null, it's a overflow. Okay, sorry, underflow. Okay, then after go to the step 5. So it's an ending part. Okay, otherwise set ptr equal to front, set front equal to front to next. So automatically part ptr part will be free and the next part will be head of the top. Okay, now then after go for the next one, linked list. See the next one is the linked list representation. So in the linked list represent a linear data structure. We call it as a linear data structures. Linked list can be defined as a collection of objects called nodes that are randomly stored in the memory. So randomly stored, why we are, that's why we implement by using linked list only. In the examples we saw in the stacks by using linked list and the queues using by linked list only, because linked list can store randomly stores the data memory. Okay, we can link between those two. And here see how the linked list will work. The node contain two fields called it as a data stored at the particular address and the pointer which contains the address of the next node in the memory. See the last of the content pointer to be null, because the end of the list is a tail part is null, no element is there. See here head part, the first is the data element, 12 is the data, and the link means here we have the address of the next element. See the next element is a 20. Maybe the 20 have some locations, we call it as an address, that will be linked or stored in the head part node. See here node is the combination of both the data and link. So the node have the link bit, so the link of the next node element. Okay, then go for the next one. Here uses of linked list. So linked list represent and continuously represent in the memory. Continuously represent in the memory means it stores, it reuses the wasted memory. Okay, then after can be raised by whenever the memory and link it together to the make a list. Okay, so we can store the elements randomly, the different locations are, but we can make it as together by making a linked list representation. Okay, optimize utilize of the space. Then after see the limited memory size. It don't need the maximum size, only it needs the limited space whatever whenever needed. Okay, then after empty node cannot be represented in the linked list, no empty nodes be is there. Then after we can store the values of a primitive types of objective in the single linked list. Okay, see the next linked list representation. See the example, head data item. Afterwards we have a next node item. Okay, so data item, next node item. See last one is the null means nothing is there. Okay, then after go for the memory representation. See here randomly, what is the meaning of randomly storing means, see in the picture here 37, 45, 82, 69 are the different elements, first, second, third, fourth. See here the linked list have 4 elements. See in the bottom of the information and the next, maybe the elements will be stored whatever or maybe the elements may be stored in a different locations, but automatically those link with the next node addresses. Okay, we call it as a random representation. Okay, then after go for the next one. See types of linked list. We have a different types of linked list. So see here first one is a single linked list. So in the single list we saw head node, and after the head node we have only one box, we call it as a link box, one link box only, we call it as a link. Okay, so we both part of the, we call it as a node when data part and link part, the combination of data part and link part we call it as a node. First one is the head node, then after next last one will be empty because no node is connected to the last node. Okay, See, the next one is the double linked list. See, in the double linked list, first one is the head part. After that, we get different types of or different elements like 10, 15, 20. See, in the first head part, first one is the before 5 is before 5 means here the 5 have a left part and right part. In the left part, then into mark is there. Why? Because this is the head node and no node is in before that. And the next part is an arrow mark like the next node's address. So in the double linked list, we get middle is the data and data's left is a link between the before node and data's next node. And that means right side we get the address of the next node. So in the double linked list, we have two links. So left link and right links. The elements are before elements and the elements after element. We can represent in the double linked list. Okay. Then after go for the next one, circular linked list. In the circular linked list, see the head part, 5 is the head part and the 20 is the last one. So right part, we call the 20's address will be linked to the first head part. So we call it as a circular linked list. The elements will be circularly combined. Okay. Then after, how we are using the single list. See in the next one. See single linked list. In the single linked list, only we get two parts. Like first one is the data part and second one is the pointer to the next node. So here then node we call it as this is a combination of data and next is called as a node of a single linked list. Here the single linked list will be empty. So empty means no list is there. The empty means here the next one is nothing is there. Okay. Next, see the double linked list here. Previous data's address, data and next element's address. We call it as a double linked list. Both the data will be stored. See in the picture. Okay, previous nodes link, data and next nodes link. Okay, then after go for the next one. Circular linked list. See in the circular linked list, 10, 20, 40, 55, 70 are the different nodes. Here, first one, second one, third one. After the last one, go to the first one. So the last head part, last C's address will connected to the head part. We call it as a double linked list. Okay, again, they go for the next one. Operations of the linked list. See the different operations in the linked list. Creation. So we know the linked list creations. We can create the linked list or we can insert or delete the elements in the linked list. See in the insertion and deletion of a linked list means we can insert the element at the beginning of the list or we can insert the element at the end of the list. Not only that, we can insert the element any position of the list. Okay. Then after traversing. Traversing means forwarding or backwarding of the list. Okay. Searching. Then after searching means we can find an element in the linked list. Maybe different type elements. Okay. Then after first we are traversing in the linked list. How? See in the picture. PTR equal to head means the top first element head. Then after while PTR equal to not null, then PTR equal to next. It moves to the next element. Okay. Traversing. So traversing a list means 1, 2, 3, 4. We can pick. We can set the elements like PTR equal to start. So the steps 3 and 4 will be repeated up to the null point. So we are getting null means no element is there. So apply the process to info PTR. PTR equal to link PTR. Those are the elements will traverse 1, 2, 3, 4. Okay. Then after we can search the element also. See here the search element. How we can search. See here we have a different types of elements. First we should take it as a temp element. After taking the temp element, we can searching element or temp element. Both are matching. Then we will get the searching elements. Okay. Then after we can delete the node in the linked list also. So by deleting the node, we have a three positions like at the beginning of the linked list, at the middle of the linked list or at the end of the linked list or at a given position in the linked list. Okay. So we should delete the element anywhere. For here see the one algorithm for check whether the head is null. If the head is null, empty, so we can't delete anything here. Then after go for the not empty list. In the not empty means here the list will be empty, not empty, we can delete the head element or can the position element. After checking that element we can delete it. Okay, then after go for the next one, deletion at the beginning. Okay, see in the beginning head equal to node A or a head equal to node B or the header maybe. By deleting the elements, after deleting the elements will be moved to the next location. After after deletion, head equal to B and node equal to C, next node equal to C. Why? Because we deleted the first element, node A. Okay, so like in the same way we can delete the everyone. Then after, this is the today's class. Again we can learn about the stacks and queues next classes. Good day.